process is a running instance of a program. The program sits on disk as a static file, but the moment you execute it, the kernel allocates memory, creates a process, and gives it a unique process ID, or PID.
Every process also has a parent process ID, or PPID, pointing to the process that created it. The kernel assigns PID 1 to the init system, and every other process descends from it, forming a hierarchical process tree.
The parent process creates a child through a fork system call, which duplicates itself. The child then typically calls exec to replace its copy with a new program, while the parent continues running independently. Appending an ampersand to a command runs it in the background, returning shell control immediately. The shell prints the background PID, and you can continue working while the process runs concurrently. Signals are how the kernel and users communicate with processes. SIGTERM signal 15 asks a process to terminate gracefully. The process can catch this signal, perform cleanup like closing files or finishing transactions, and then exit on its own terms. SIGKILL signal 9 terminates a process immediately and unconditionally. The process cannot catch, block, or ignore it. No cleanup happens. Open files may corrupt, transactions may break, and data can be lost. Always prefer SIGTERM. It gives the process a chance to shut down cleanly, preserving data integrity and system stability. Reserve SIGKILL as a last resort for processes that are unresponsive. It is a forced kill with no opportunity for graceful recovery. We begin by launching 2 background processes using the sleep command. By appending an ampersand to each, we instruct the shell to execute them asynchronously, allowing us to continue using the terminal while these tasks run in the background. Each command returns a unique process ID, or PID, which we will use to manage them. To view our active tasks, we use psaux. This command provides a detailed snapshot of every process running on the system. By piping the output through grep, we filter the list to focus specifically on our sleep processes, clearly displaying their PIDs and current status. For a dynamic view of system health, we use the top command. The flags is B and N1 force it to run in batch mode for a single iteration, providing a static, readable snapshot of CPU and memory usage across all active processes, including our background sleep tasks. Now let's terminate one of our processes. We use the kill command with the nash15 flag, which sends a SIGTERM signal. This is a polite request for the process to shut down gracefully, allowing it to perform any necessary cleanup before exiting. We verify the result by running psaux again. As expected, the process with the PID we targeted has disappeared from the list, confirming that the SIGTERM signal successfully requested the process to terminate. For the remaining process, we use kill-9, which sends a SIGKILL signal. Unlike SIGTERM, this signal cannot be ignored or caught by the process. It forces the kernel to terminate the task immediately, which is useful for unresponsive or stubborn applications. Running our grep filter once more confirms that the second process is also gone. By using these 2 signals, we have effectively managed our background tasks, moving from a graceful shutdown to an immediate, forced termination. To demonstrate a more efficient way to manage multiple instances, we launch another sleep process and then use pkill. This command allows us to terminate processes by name rather than PID, making it an excellent tool for cleaning up multiple related tasks simultaneously. Finally, we run our verification command one last time. The output confirms that no sleep processes remain, demonstrating that pkill successfully identified and terminated all instances by their name, leaving our system clean and free of those background tasks. By chaining commands with the ampersand and semicolon, we launch a background process and immediately trigger pkill. This demonstrates how the shell handles multiple instructions in sequence, allowing us to spawn a task and clean it up instantly without needing to manually track its specific process ID.